I will be presenting a project that was launched 4 years ago, and it ended last February. It's a project that is very challenging because the idea was to bring automation in airplane manufacturing, and you will see that we have investigated using humanoids. So this is just the technical things on the project where it was submitted. I wouldn't spend a lot on the Airbus needs, but basically Airbus has identified two kinds of tasks. Some tasks that are called added value tasks that are interested for workers to be done, and the tasks that are called non-added value tasks. It means all the tasks that they don't want, or the workers don't want to do anymore for multiple reasons. The problem is that you have, of course, a lot of robots in industry, but if you compare with car industry, the main difference here is that in general in assembly lines, in cars and other products that you know, the robots often works outside of the product, but here the robot needs to work inside the product, and it makes it a lot of challenging because we cannot exclude the human workers, okay, from the workplace, and the areas of the work are mainly the fuselage or around the fuselage, which makes it also confined, and you have also many areas where you cannot access easily, even for human workers. And you cannot use, of course, fixed-base robot. You cannot use railed ported robots. You cannot use mobile with wheels because of these conditions that you could see from these pictures. Especially, for instance, the cargo area you cannot enter if you are not basically ported somehow. So, as can be seen from these pictures, mobile robots cannot access, rail ported are not possible. The robot must work, and after discussing several times, we decided to investigate using humanoid robots inside the manufacturing. So those are the constraints, two mainly, so to work with human workers and to share the same tools with human workers. So we gathered a small consortium after discussing with Airbus, which is of course the end user, who's basically the co-coordinator of this proposal, so the Airbus Innovation Center at that time. Then our colleagues from INRIA, there is two groups, one working on walking with Pierre-Brice Vibert and the other one working on vision, François Chomette. The DLR, our colleagues under Christian Ott, Maxime Roa, I guess he's here, and Aline Albuchafer because they have a humanoid, which is torque controlled. Us CNRS at LIRM in Montpellier, and the GRL in Japan, because we have a position controlled humanoid. And then we have our colleagues from La Spienza Roma, because they have expertise in, because of the safari of human-robot interaction and safety. So that was a small consortium, but the idea was to try to use multi-body contact planning technology at that time that we developed on humanoid robots, use 3D SLAM for localization, visio and force whole body control, and also safety requirements. The demonstration would be used on a scale 1-1 airplane mock-up, and I will talk about it later on. And the showcase must be done with two robots, one Torque, which is the Toro, and the other one, the HRP4, that we have at Montpellier. The good news for roboticists is that, of course, it's an industry, then it's making a product, and obviously everything, every single piece, okay, inside the airplane is modeled, and we know exactly its model, its inertia mass, etc. So it makes all the techniques that was developed in robotics, in planning or model-based control, plausible to be used here. So this is the mock-up that we used for the final demo. It's on 1-1 scale, A350 fuselage, I mean part of the actually the cockpit or the starting of the cockpit area, and we have to demonstrate that the robots could climb the stair, go inside, and do some small tasks. We decided one after discussing with our colleagues, and I will show only one. The others are made not necessarily in the airplane, but they was made in the laboratories. So now I will just show this video, which is in fact the final demonstrator that held in 21 of February. So in February 21 of this year, it's the first time in history that humanoid robots entered a shop floor manufacturing and Airbus, basically. And here we start with the Toro. So the idea was that the Toro takes these brackets. The brackets actually is, there are about 300, well, there are, sorry, 2 digits. I cannot tell the number, but there are 2 digits, thousands of them to be placed everywhere in the airplane. And this operation is selected because it takes about 12 minutes to put one, to draw the pattern, of course, in the airplane. Generally what we do is that we draw the patterns in the fuselage, and then the persons will go glue it there at the position that is dictated by the CAD model. So the idea is to remove this, to remove all this process. I mean, the printing of the patterns will take 8 minutes, and the assembly the remaining. So the idea is to save these 8 minutes, to reduce them as much as possible by allowing the robot to localize by itself. As you could see in the videos with our colleagues, we decided to do this without ropes, without control, so the robots are operating really autonomously without any protection that you could see here in the videos. It was very hard to convince, but at the end, after doing the trial several times with the protection of the humanoids, we decided to do 2 of them without. So Toro has used the April tags to localize, but we made everything by using SLAM, basically. And what you could see here is that the robot going directly from the first stage, climbing the stairs, getting to the shop floor. Here you see that the robot is localizing using only SLAM. So the reason why it's adjusting this time is because, sorry, it is because we cannot do like online readjustment. We go by steps and then we correct at the end. We go by steps and then we correct by the end. But this is easy to make it because I have just the video, in fact. Yeah. So, and then you can see here the robot is HRP 4. The power is not the power supply is not. I mean, is provided here, but Airbus allows to have the power supply provided inside the whole factory. So for them, it's not necessary that the robot have autonomy in terms of power supply, as far as it can plug and then plug itself to a power supply. Of course, we didn't test this functionality, but this was one of the recommendations on the final things. So here you see the visual servoing. So here we grasp the bracket by using visual servoing. And in fact, what we did in this demo was that the 2 robots goes near the fuselage, and then at the end they do assembly. They assemble these 2 together. So so here I had to remove the things myself. So it means that in practice, probably some dexterity is needed, but maybe we can change even the brackets so that you don't need to remove these sticks so that you can glue them. So here all the robot is using SLAM to localize inside the aircraft. So it was. I have heard one of the talks, people complaining. It's true that SLAM has of course, it's an established technology, but in fact, putting it on the robot, making it in practice working, it's another story. So we had to combine a bit of SLAM and visual servoing so that to be precise. So what you could see in the video here, Toro is kneeling basically with his knees, taking a support contact so that it can has a better or larger reaching area so that he can plug, of course, the bracket, whereas HRP is using also this multi-contact technology so that it takes hands. So the idea is that you can take as much support with the contact as you want to make your robot stable, to increase even the operational space force, etc. And you will see here the robot assembling directly the bracket. So as I said, these 2 robots has 2 different technologies. One is position controlled and one is torque control. I don't have any idea what is the best for the moment. Both have realized everything. Toro here is working completely in torque. I mean, the working pattern is using torque control. And so after dismantling, the robot has to exit, of course, the area. So this is what HIP4 is doing now. And then it has to exit the things. We can repeat, of course, this several times. And we did it, actually. We did it more than 4 times inside the thing. So now we will remove the table, and then you will get Toro going out of this, and then you will see the walking on some rubbles. And then for HRP4, you will see the design of a new technology that allows the robot to be contactless compliant. It's using whole body capacitive sensing to have protection and safety for the robot so that it can feel humans around. This is just showing the Toro going into these rubbles. So you see Maximo Roa here, our colleagues from DLR. And then you see the working, which is also full control, full torque-based working, which was impressive because, in fact, they didn't use anything special, just using the same pattern generator and the compliance on the legs, sorry, on the feet allows to do such kind of things. I will end up the video just by showing this the technology that was implemented on the HRP4. So with a company in France, a small company, SME, near Montpellier, they developed the capacity. We worked with them so that they adapt the capacitive sensing to whole body humanoid. And here you can see that without touching, the robot is completely compliant. So I skip this now, and then I conclude. So I think that most of the limitations we had are due to the hardware, are due to the limited robustness in the perception. We had to work a lot on that. We didn't implement recovery strategy because it's more of engineering work. But the continuation is subject to clearly identify who will provide the system. So now the problem is who will design a manufacturing humanoid robot. And I would like to stress this to say that it's important to fund projects on AI. But AI in robotics means that you have a very good hardware, and I would suggest also to fund projects on on real intelligence hardware, so that we could advance on this system, because there are many other industries now that are interested by the technology. And of course, there is this problem of onion cartel, social acceptance, etc. And that's all. I think the other points you can just read them, and there is more recommendation to come on a paper that I wrote, submitted to RAM. Thank you.
Thanks a lot.